This is lesson 6.3, solving systems by substitution. So far in this chapter, we've learned that a system of linear equations is two or more linear equations with the same variables. We know that the solution to a system is where the lines cross each other or when the equations are equal to each other. And there's three possibilities. There could be one solution, no solution, or infinite solutions. We've learned two methods to solve systems. The first was solving by graphing. That's when you graph both lines and find where they intersect. We also learned how to solve by elimination. This is when you use algebra to eliminate one of the variables and solve for the remaining one. Today, we're going to learn the third method to solve systems of linear equations, and it's called substitution. So this is another algebraic method similar to the elimination method. I've listed out all the steps here. How to solve systems using substitution. The first is you're going to choose either of the equations and isolate for one of the variables. It doesn't matter which one, x or y. So in this example, I just picked the first equation and I decided to isolate for y. Looking at the two equations, that makes sense as the easiest choice because the y has just a coefficient of 1 in front of it, so it makes for easy calculations. So I got that y is equal to 4 minus 2x. It doesn't matter what form it's in. All we want to do is isolate for this one variable. The second step is you're going to take what you just found and substitute it into the equation you haven't used yet. In other words, you're going to replace x or y with the value that you just found. So the equation we haven't used yet is the second one, which I've written out here. And we just found what y is equal to. So we're replacing y with what we just found to be 4 minus 2x. Make sure that you're replacing it in brackets. This is critical. If you don't have brackets, then this 4 out front is not going to apply to every single thing inside. The 4 is multiplied by the y. We're replacing y with 4 minus 2x. So the 4 has to multiply by everything inside those brackets. The third step is you're going to use algebra to isolate for the remaining variable. So once I've subbed this in, I have an x here and I have an x here. So I only have one type of variable to solve for because we've removed the y. So we're going to use algebra. We'll get rid of the brackets first, multiply the 4 in. That would get 16 minus 8x. Then we would combine our like terms. We can do that next. So we have the 3x and the negative 8x. That's going to give us negative 5x. Then we'll also combine our constants by bringing the 16 to the other side. 1 minus 16 would be negative 15. So in our final step, we get that x is equal to 3. So remember, when we're solving using algebra, you have to collect your like terms, and whenever something is moving to the other side of the equation, the sign changes. So what we've accomplished is we've found the x value of the solution, but we don't have the y value yet. So this last step is similar to the last step of elimination. We're going to take the point that we just found, and we're going to substitute it into either of our original equations to solve for the remaining variable. So we have x. I just picked the first equation, and I've replaced x with what I just found to be 3, making sure to put it in brackets. Now I can isolate and solve for my variable y. This gives me 6. I bring it to the other side. It becomes negative. I get y is negative 2. So therefore, my solution is 3, negative 2. We'll do another example, a little faster this time. So we want to solve this system by substitution. We don't have to rearrange things or stack them or do anything that we would for elimination. All you have to do is pick either of the equations and isolate for either of the variables. I decided to pick the second equation and isolate for x because it looked like a bit easier to do. The math would be a little simpler. So I took this equation, I brought the 8y to the other side, and then I divided everything by negative 1 to get x on its own. So I have that x is equal to 5 plus 8y. The second step is where our substitution comes in. I'm going to substitute what I just found, x equals 5 plus 8y, into the other equation that we haven't used yet, and use this to solve for y. So the first equation is the one I haven't used yet. I write that out, and I'm replacing x in brackets with what I just found, 5 plus 8y. Now I'm going to use algebra to solve for y. So I'll distribute the 2 into the brackets, giving me 10 plus 16y. And then I'll combine these two y's together. 16y minus 4y gives me 12y. At the same time, I'll bring this constant 10 to the other side of the equation, which makes it change sign. 7 minus 10 is negative 3. And then our last step to get y on its own is divide by 12. So negative 3 divided by 12, that reduces to negative 1/4. So we have our y value as negative 1/4. We'll get our corresponding x value by substituting this into either of the original equations and solving for x. So I just picked the first equation. I replaced y in brackets with what I just found, negative 1/4, and I solved. This works nicely with the fractions because negative 4 times negative 1/4 just gives me positive 1. Makes our math easy. We subtract 1 on both sides. We divide by 2. We get that x is equal to 3. So therefore, our solution is 3, 1/4. I guess that should be negative 1/4. One more of these kind of more common examples where you have one solution, and then we'll look at our special cases. So solve this system using substitution. We're going to pick one of the equations and isolate for one of the variables. I'm going to pick the second equation here because it looks like simpler math because the coefficients are just 1. So I took that equation and I decided to isolate for x, but I could have isolated for y if I wanted to. That gives me 3 plus y. Now I'm going to take the equation I haven't used yet, the first one, and replace x with what I just found to be 3 plus y, making sure to keep it in brackets. Now I'm going to use algebra to solve. So 2 gets distributed into the brackets, giving me 6 plus 2y. I combine my like terms. The y is combined to give me negative 3y, and the 6 goes to the other side. We get that y is equal to 2. The last step is we take either of our original equations, I just picked the second one, and replace y with what I just found to be 2 in brackets. Now I solve. This is a pretty simple math here. We just add 2 to both sides, so I get that x is equal to 5. So you can see that there's a lot of similarities between substitution and elimination, and depending on your preference, there might be one you like to use more than the other. Here's one of our unique situations, our special cases. We want to try to solve by substitution. So we follow our steps like normal. We pick the first equation, we isolate for y. We take the second equation, we replace y with what we just found. We go to do our algebra to try to isolate for the x. But what we find is that the x's cancel out. We had negative 6x and plus 6x. So that just becomes 0. We had negative 10 plus 10. So that becomes 0. So we're left with 0 equals 0. We know that this has to be infinite solutions because 0 does equal 0 at all times in all situations. The other way that we know that this has infinite solutions is because these lines are identical. If we take every term in the second example or second equation here and divide it by negative 2, then we would get this first equation. So they are identical lines. This is similar to the case with elimination. You get 0 equals 0. That means it's infinite solutions. The other special cases here, when you have no solution. So same thing, we're trying to solve by substitution. We pick one of the equations, isolate for the variable. We plug it into the other equation. We do all our algebra. When we get to the end, we get that 0 equals 13. This is an indication that there is no solution because this is not true. This is impossible. 0 does not equal 13. There's no solution. The other way to check would be to bring both of these equations into slope-intercept form and check that they are in fact parallel lines. So I want to go over how we can check our work because there is an easy way to do so. So for each equation, like let's say you get an answer, you get an x and a y, and you want to check that it's right. So for each of the equations in your original question, just replace the x and y variables with the solution values that you just found. Then you want to simplify that and ensure that the equations balance, left side equals right side. So for example, if we wanted to check one of our earlier examples, check that 5, 2 is a solution for this system here. We're going to take the first equation and you're going to replace x with 5 and y with 2. And then you solve or you simplify. So this would give us 10 minus 10. That does in fact equal 0. Since our left side equals right side, our equation balances. So yes, 5, 2 is a point on this line. We'll check the other line as well. We replace x with 5 and we replace y with 2. And then yes, our equation balances. Of course, 3 does equal 3. So since that means that this 0.52 also exists on this line. If that point exists on both of these lines, it means that that's where they intersect. So it is in fact a solution to that system. To end off this lesson and the 3 methods that we've learned, just a brief comparison of the 3 different methods. So for graphing, the cons is that it takes a bit more time because you have to convert the equations and set up the graphs. So graphing can be a bit time consuming. The other problem is it's not always exact. If lines don't go exactly through the grid lines, you kind of have to estimate what the intersection point is. But a pro is that it provides a visual solution, which helps a lot of people. And some students might just prefer graphing. For the algebraic methods, elimination and substitution, some pros is that it can take less time and it does provide exact solutions. So you don't have to estimate anything. But a con is that there's no visual aspect to it. And some students might benefit from that. They might prefer graphing, or maybe they just aren't really a fan of algebra, so they don't work as well with elimination and substitution. But on the other hand, some people might prefer algebra over graphing way more, so then these methods are the ones that they prefer. The good news is that you can solve systems using any of these 3 methods and you should get the same answer, but for the test and for this course, we need to know how to do all 3 of them. So at this point, we now know how to solve with graphing, we know how to solve with elimination, we know how to solve with substitution, and we know how to check our work.